Club. We're the Developer Student Club at UBC, a program sponsored by Google developers to create community groups for students. We offer learning opportunities, online courses and certifications, events and workshops throughout the year, and we give students the chance to participate in Google's annual solution challenge. So if you're interested in joining our future events, go ahead and scan the QR code. I'll give you guys a quick minute to do so if you'd like. Sweet. So yeah, I just want to talk a little bit more about this year's solution challenge. This year's mission is to solve one or more of the United Nations 17 Sustainable Development Goals using Google technology. If you're interested in joining a team or learning more, a good place to start is our design workshop series we're currently hosting. So you can check us out on our Instagram or on our site, ubcdsc.com. But yeah, without further ado, let's get into the workshop. So let's start with some quick introductions. Gagan, would you like to start us off?
Yeah, hi. So hi everybody, I'm Gagan and I'm the president of DSC at UBC. And I'm a machine learning engineer and a full stack software developer as well. And I've been working on a lot of different ML projects. And I hope to share a lot of what I've learned so far with you guys today. Awesome. Yeah, Richard, do you want to continue?
Sure. Yeah. Hi guys. My name is Richard. I am a 5th year computer engineering student at UBC, and I'm currently doing a co-op at Sierra Wireless right now, where I'm working as an embedded developer. And so, yeah, I have a deep enthusiasm for machine learning and cloud computing as well, but I also enjoyed solving like everyday problems through code.
Sweet. So yeah, once again, I'm Justin. I'm a 3rd year, I guess technically 4th year comp sci and management student at UBC. I'm currently working as a software engineer at RBC. And at work, I deal with like data platforms and visualizations, deploying data pipelines and microservices to cloud environments, particularly OpenShift. And I do some Java development as well. Outside of work, I like learning like these new technologies through like small projects and clubs. And I also do a lot of photography and video. But yeah, if you'd like to chat with any of us, feel free to scan our LinkedIn QR codes. But yeah, I'm sure all of you guys are waiting to get started.
Just sorry, before we go on, Gagan, do you want to do the quick photo with everyone really quick before we get started?
Yeah, sure.
All right, cool. So just if everyone wants to put on their camera for a sec, and can you just, I think you need to stop sharing the screen so we can get the whole gallery.
Yeah, sure.
But yeah, just to get everyone on camera and we can share on social media and yeah. Cool. Come on, get those cameras on. Let's go, everyone. gotta look good for the gram. All right, say cheese or code or whatever sounds good. I don't know. Awesome. Cool. All right. And with that, we can begin the workshop.
Sweet. Awesome. So yeah, what we're all here for today. Today's workshop, as you know, is an intro to machine learning. What we'll cover is a quick introduction to some common concepts we'll be talking about and go over some basics of machine learning and natural language processing, which is a big focus of our workshop. After that, you'll see some demos experimenting with transformers and also deploying machine learning web apps with Streamlit, just to show everyone how you can use machine learning in your own projects today. We aren't really going to go into the details of how, like machine learning works, go into like the backend that much or into any like math or statistics. As you know, these are quite like complex topics and people spend years to gain expertise in them. Instead, we'll kind of focus on the basics and give you like practical examples how to use a lot of the tools that are out there to take advantage of machine learning. So let's go over some concepts so we're on the same page. First of all, since we're showing some demos, it'll be best if you have some understanding of Python basics and Juypter notebooks. We'll be showing you some code, so understanding some syntax will help. And on the other hand, Juypter notebooks, you can think of them as it's an open source web application that allows you to create and share live code in the form of documents. It's kind of like an IDE/presentation tool rolled into one. It's like an interactive Google Docs, if you want, that can run code. So let's start off at the top, AI machine learning. If you're new to these concepts, it might be kind of confusing to understand what each topic covers. AI refers broadly to an idea where machines can execute tasks smartly. As a whole, artificial intelligence contains many subfields, including machine learning, deep learning, computer vision, natural language processing. Machine learning, on the other hand, is a subset of AI. It relates to machines learning from data and applying that learning to different tasks without the need for human intervention. Basically, to automate different methods to find insights on data without being explicitly programmed to do so. In reality, there are many different types of machine learning and many different methods, such as neural networks, statistics, and even physics. Now, another buzzword you'll hear a lot is natural language processing. And like I said, it's a key focus of what we'll cover today. NLP, which is, just to save on some time, I'll be referring to these with like NLP, ML, AI. Again, is a subset of AI, but there's quite a lot of overlap between AI, machine learning, and NLP in other fields like deep learning. So NLP refers to computers being to understand, interpret, and manipulate the human language. It covers quite a few disciplines from computer science to linguistics, but we'll mainly focus on the intersection of NLP and ML today. Another term you'll hear come up a lot are machine learning models. A machine learning model is a file that's been trained to recognize patterns in data. To kind of simplify things, you can think of the model as kind of a thing that's saved or like the output after running a machine learning algorithm on training data. It kind of represents what the machine has learned and the information required to make predictions. So these models are created by different algorithms, which can range from simple equations from the equation of a line to complex systems of logic and math. There are many machine learning algorithms like linear regression, decision trees, neural networks, but like we said, we're not going to go into details of these because it's not like we can cover them that well, and it's not what you really want to know to use this in your hackathon projects. But you might have heard of terms like supervised and unsupervised or reinforcement training, which again, we won't go much into detail of, but are basically different ways to train a model on a set of data. Finally, one thing we'll definitely be covering is the transformer. The transformer is a deep learning model primarily used in natural language processing. They're designed to handle sequential data, such as natural language for tasks such as translation, text summarization, or sentiment analysis. We'll be using the HuggingFace Transformer, which, so HuggingFace is a company and they provide this library. We'll be using this later in a demo, and it provides us thousands of pre-trained models to perform these tasks. Its aim is to help make NLP more accessible and easier to use for everyone. Oops, sorry. And then finally, I know this is taking a little bit, but just to make sure we're all on the same page, some of the tech we'll be using, I'll go over quickly. So Tensorflow, it's an end-to-end open source platform for machine learning. It's made by Google, and basically it bundles together a lot of different machine learning and deep learning models and algorithms. PyTorch, it's another open source library used for applications like computer vision or natural language processing. This one is made by Facebook. And then Streamlit, I learned about Streamlit recently. It's really cool. It's an open source Python library that makes creating and developing web apps really easy. So we'll give you as a demo later of how we use it. And then finally, again, HuggingFace Transformers. It's a popular Python library that provides pre-trained models useful for NLP. So before we cover some more basics of machine learning and natural language processing, I kind of want to go over the scope of AI and machine learning. As I kind of mentioned, this workshop focuses more on using surface level tools to like implement different machine learning functions in your own projects. But since machine learning has been made really accessible for these tools, on the other hand, understanding how machine learning works is a really extensive process. So yeah, I wanted to quickly look at this roadmap, this resource set I've taken a look a few times. And it's really helpful to kind of understand like what goes behind like, you know, pursuing a career in machine learning engineering or something like that. All these links will be available for you later in our GitHub, but we'll also give that to you in a sec. So yeah, I just want to quickly show you, like, this is a really good roadmap put together by someone. So it's like becoming a AX expert. We're particularly interested in going into this machine learning section. As you can see, obviously, we would go through fundamentals with like math, databases, data pipelines, how to like extract, transform, and load data, regular expressions, data formats, all this good stuff, Python programming, again, like data analysis and stuff like this. And from there, typically people will go towards data science, which there's a lot of statistics and maths in there as well. Visualization is a really important part, using data for like business value. And then finally, towards machine learning, again, a lot of these terms and concepts, the different training methods and then use cases. We'll be covering some use cases later today, specifically, I think, sentiment analysis and question and answering. And then, yeah, from there, it goes on to more deep learning, which I'm sure everyone is like, it's like a lot popular these days with like neural networks. But yeah, I just want to give you guys a quick look of what's behind, pursuing machine learning. So yeah, how does machine learning and NLP work together? The field of natural language processing has actually been around for decades. It first started out as like a handwritten set of rules just to help machines understand languages. I personally don't know exactly how they're implemented, but in my head, it's like if I can just think of like if statements to like understand language. But yeah, then around like the 1990s, statistical algorithms and mathematics began to be more used in NLP, and machine learning was used as more like computational power was available. And now in the present day, NLP is like primarily dominated by deep learning style machine learning methods, as they bring a lot higher level of accuracy. So machine learning for natural language processing involves using machine learning algorithms to understand the meaning of text documents. As you can probably know, computers have a hard time with dealing with unstructured data. For example, social media posts, subreddits, news, emails. So NLP is used to parse through this unstructured data to extract useful information. And then machine learning is used to automate this process and deliver more accurate responses for learning through your past interactions. Some example use cases of NLP and machine learning today. Sentiment analysis. For example, I'm sure a lot of you guys might be aware, hedge funds using it to analyze a subreddit's feelings towards a particular stock. Question and answer. I know at work we have like a virtual help desk where they use this to give like answers to like DevOps questions and stuff like that. Most of the chatbots you use need to understand your responses, and ML helps it give you more accurate interactions. And summarization. I'm sure we've seen like TLDR bots in Reddit. So yeah, now that we've gone over some of the basics, I'll let Gagan take over and give a demo of these machine learning functions in use.
Yeah, sure. Yeah, thanks so much for the great presentation. So far, I'm actually explaining what we're going to be talking so far. And before we actually get into the demo, I actually want to talk about like a few really good technologies that are available to us for ML. And most important, I think the most powerful one is Google Collab. And so as you guys know, we are actually powered by Google developers as well. And so I actually want to share something, really cool technology, which is actually Google Collab. And Google Collab is sort of like things like for Google Docs, where you can actually share your code, where you can share the files, work on it together, and actually just interact and share your code with people instantly. And Google Collab is exactly that. And it's basically a Jupyter notebook on the cloud, and where you can share with people. You can share your code around. You can have a proper display with all the matplotlib functions up on it. And it also comes with pre-installed libraries like pandas, numpy, matplotlib, and a lot of these actually are super easy to collaborate as well. As I've already mentioned, it's super easy. It's basically a Google Drive. It's basically stored in your Google Drive. So just sharing a Google Collab link is basically sending someone a Google Collab, basically a drive link that they can just click on it and it opens a Google Collaborate notebook. And the biggest and the most important part is we get free GPU usage for it, and we get it's actually powered by NVIDIA K80 and T4, where we get 12 to 16 GB of free GPU users, and it's completely free for everyone. And like you just need a Google account to sign up. And I'm sure almost everybody, like all of us, have a Google account. that we use every day. So just with having a Google account, we get like a 16 GB GPU to run any of the machine learning or models that we have built. And I think that's pretty cool. And I'll actually be going over like how to use Google Collab and how does Collab actually work in, and why it's so easy, why it's so much more easier than any other Jupyter notebook that's available to us. And I think as just already mentioned, we do like one of the most important libraries that we'll be focusing on is transformers. And transformers actually was brought to us by HuggingFace. And so you guys see this really cute emoji, and that is actually the logo of HuggingFace, which is an NLP focused startup. And they have a really large open source community. And so you guys can check them out on GitHub as well, or you guys can also go to our GitHub link which I've shared in the chat, and you guys can go and find all the resources related to Hugging Face and Streamlit as well. But I'd actually like, so transformers is basically something that like transforms we see a data set into some any usable data form. So it's sort of like for now at least this way we can actually imagine it like a black box where we actually input data and get some output which is more relevant to us in the use case. But transformers in its core is actually it's a bunch of pre-trained transform models which have been trained on data sets as large as approximately like 1 terabyte of data. So they actually so they're pretty good on it, and we can actually be sure that the data that has been that it's I mean the model that we're training is pretty good and what we're looking for. And the biggest advantage of using transformers is it's a straightforward API, just one simple call to the API, and we get our answer, we get a result what we're looking for. And to use transformers, we just have to use transformers, we just need to install pip install transformers, and we do have transformers on the system installed. And finally, we have a really cool tool which is called Streamlit. And Streamlit is basically like a Python library as well. But the biggest advantage of Streamlit, it creates an instant dashboard that we can actually show off or show off all of our like ML models that we build and any of the visualizations that we have as well. And I think the biggest advantage, like, so one of the biggest challenges when you actually want to export ML, ML products is that so once we do create a model, we actually create like a Flask API to wrap around it. And once we do create a wrapper for it, then we create a front end with like maybe say JavaScript or something, and then we connect all of that, and that process can take really long, and it's a pretty slow process as well, because we got to kind of make sure all the backend and the front end connections are working. We have a big enough server to host a machine learning model as well, and there are a lot of things that come into play. But with Streamlit, it's just one call. So we just set up a Streamlit call, and we just do Streamlit run app.py, and we get this beautiful looking dashboard with a sidebar, and with a sidebar that displays our results beautifully. And it's really easy to use, as you guys will probably see in a demo as well. But it's really easy to understand how Streamlit works, and it's super easy to code up some really interesting and really cool looking dashboards as well. And I think with that we do have a really cool demo. So I think you guys can just scan this QR code or go to our GitHub link as well. So I'm just gonna give you guys a second to do that. See, I think we posted the link on the Zoom chat as well, and you guys can just visit the link, and then we'll actually so once we do actually go to the GitHub code, I'm sure like if you guys want to follow along, you guys can do that too. But and one of the most important like things that we do have here is we have the open and collab page, which is, as I've already talked about, Google Collab, which is a really cool way of like sharing your notebooks. And so I have the Google Collab one linked down here. So you guys can just click on this link, and once we do click on the link, it's gonna open up this Jupyter notebook. And I think one of the really cool features of using Collab here is actually it's pretty neat, and we do have a table of contents here, and we do have everything set up here as well. And I think you guys can see as well that we do have 12 GB of RAM available here that we can use in our runtime. And I think that's pretty good considering like whenever we do usually run our like on a normal Jupyter notebook on our server as well, it's not we technically do not get so much of RAM at one point of time. So yeah, I think so. Just getting into the demo. So we'll be using all of the models that we'll be looking at today are actually by HuggingFace. And as I already mentioned, we'll be using the Transformers library. And to install the Transformers library, we just have a simple like pip install Transformers. And again, just like any other Jupyter notebook, we just do we just do shift and we just do shift enter and we run the cell. And so since I've already installed Transformers, so it says just requirement already satisfied. And in the Transformers library, we'll be actually using the pipeline function, which basically has pipelines for all the cool things that we'll be going through. Just as a table of contents, we'll be going through sentiment analysis, question answering set, bots, mask fill, which is a really cool thing, and NER, which is actually called named entity recognition, which identifies whether something is whether it's a person's name, or organization name, or currency amount, a date, or and so on. And then we do have text generation as well, which is a pretty cool thing. And finally, we have text summarization as Justin mentioned as well. So we do have all of these things, and we do have a live demo to show you guys as well. So as I mentioned, we'll be using the pipeline feature, and so just to show you guys an example, so we do just to show how easy it is. So we just have like 2-line code, and we get our result as well. So I'm just gonna run this code. I'm just gonna run the code here. So we do have a sentiment analysis cell, and what we basically do here is we call our pipeline, which is sentiment analysis, and it runs a cell. And so we do have a very positive one, which says we are very happy to include pipeline to again. This was basically a dummy text that we actually got from the library itself, and we do see that it's an extremely positive score, and the label is actually positive as well. And actually moving on, so we have a really quick dashboard that we have set up as well that you guys can play around with, and I think we'll be going over that in the next demo. But actually, just moving on, we do have the question answering pipeline as well. Where we do have where we have a question, say what is my name, and basically a larger text, which just says like my name is Gagan, I work at Google DSC, and it gives me the answer that like what is my name. So my name is Gagan, and it does give me the right answer for it, which is pretty cool for and I think just coming to like mask fill. So this is a pretty cool feature because it's mask fill is sort of like a fill in the blank machine. And so it is actually just going to do a fill in the blank. So I had dash for dinner. So so once I do run the cell, it's going to give me 5 different answers for it, and it's going to try to find the most appropriate words that actually fit into the sentence and to make sense in this option here as well. So we get 5 options. See, I had pasta for dinner, I had pizza for dinner, I had spaghetti for dinner. And then we also have the corresponding score, which says how confident the algorithm is actually in this answer. And accordingly, we do have the token sequence, and the token string as well. So I'm sure like if you guys have any questions, you can just like post them in the chat, and we can just play around with it. We can run different queries and test how this works as well. And just if you guys want to play around with it, again, it's available on our GitHub as well. All these files are available on our GitHub page as well.
We have a quick question in the chat. So is the blank filled by machine learning model that you just wrote?
So actually, this is actually a pre-trained model. So I just had to call the model, and it fills the blank for me. And again, yeah, this is what I actually want to emphasize as well. So it's really easy to use. It's really simple and really easy to use it. because again, these are pre-trained models that have already been trained for us on a large data set. But I'm actually going to go through how we can fine-tune a particular model as well according to our needs as well. So if once we actually do, so actually moving on, we do have the NER pipeline as well, which basically detects like if we do have like a name in a sentence or not, a person's name or an organization's name as such. So here you guys can see it detects my name as like Gaga, and it says like it's a person's name. And for similarly for DSC, it detects it's an organization. And finally, we do have the text generation model. So this again, this in this pipeline, all we have to do is we just call the pipeline. And again, so I'm going to be using the GPT-2 library, and which basically stands for Generative Text Transformers. And we have, so once we do use GPT-2 library, it's actually going to generate a text. So it's actually going to fill in the blank. It's going to actually create new sentences after it. So again, so we actually come up with like we come up with different answers for it. And I actually want to show you guys something cool about like using Google Collab and just PyTorch as well. So here I'm actually going to be showing you how we can actually get one single words prediction from a sentence. So I actually have a text here which says like, let's see how this turns. And I'm actually going to change my runtime. I'm going to change my runtime. So I'm going to like, I'm going to use my hardware accelerated GPU in my Google Colab. Again, we'll be using the cloud compute from Google Colab. So there's no way you can run this on any system that you have. And I'm just going to be I'm going to be using all these Torch model. I'm going to be using Torch here to train my model. And I'm gonna use the GPT to like pre-train model, but I'm gonna tokenize it and actually modify it to according to my needs and fine-tune the model a bit so that we do get much more accurate results. And finding the text does make sense at the end of the day. So we do, so as you guys can see, we do, and we like once I do run the survey, like it's actually gonna evaluate and show us what the actual model looks like. Just a quick summary of it. So as you guys can see, there are a lot of layers in the model. So there are a lot of solution. This is a complete deep learning neural network that we've set up here. Okay, and this is as you can see, this is basically I'm not creating a new model here. I'm actually just fine tuning the model here to get a better result. And when I do run, and so once I do train Python, and I do get an extra word. So we started off with let's see how this turns, and I've got my output as let's see how this turns out. So it's actually generated an extra word which is out, and once we actually created, like we just gave them a cue, and it actually generated then new sentence out of it. And finally, the same thing can be done for like multi-words as well, where we get like a larger text as well. And we do have inbuilt PyTorch libraries that are like comparatively way more accurate than using the pipeline feature from Transformers, and where you can actually create a complete story out of something as well. And finally, coming to the last, and I think one of the coolest features as well, which is text summarization. So I think we do come across a lot of times where we have a huge chunk of text, but we want to actually cut it down to like a reasonable amount so that we can understand what's going on, but we do not lose any valuable information as well. So I actually have something about Shakespeare here, but it's too long and I don't really want to read so much. So I'm just going to use my summarization pipeline. And once I do run the summarization pipeline, it's gonna output this really simple one, which is less than 50 words. And it's going to give me the summary of the whole huge chunk of paragraph that we have here in a really simple way. And again, this is actually, so we also can use a pre-trained model by Facebook, which is called BART, which is basically a convolution neural network here, like I've showed for the GPT, like the text generation model as well, where we use a PyTorch feature. We can also do the similar thing and fine tune the model according to our needs. And once we do fine tune the model, we can finally get a much more result, a much more better result, where we do see that it actually actually reduced it from like almost like from 1800 words to just 300 words. So that so accordingly we can actually just fine tune the model and get better results as well. So now again, this might seem a bit complicated and stuff, but like, so if you can, like, I'd actually will recommend you guys to go to a GitHub repo and play around with the notebook, because then it might seem more intuitive and you guys will be able to come up with some really cool projects. But we do have a really cool dashboard demo as well. I think, Richard, do you actually want to show that and wow everyone here?
Yeah, sure. I guess I can move on to my part of the presentation. Let me screen share real quick. So yeah, Gagan just went through a lot of different tools, machine learning tools that you can use for your projects. And I'm sure that you guys probably have like a million ideas in your mind now of what you can build and all that. But just in case you don't have any ideas just yet, I'll be showing you a couple of applications that I thought of that could be practical. So if you'd like to follow along, please visit our link and download our repository, and we can go through this together. So I'll give you guys a couple of seconds here to open the link up. But after you have our repository downloaded, feel free to run this command in your terminal. Run streamlit run app.py, and that'll start up our web application, which is the first practical use application that I'll be going over.
Sorry,
so once
Richard, I probably need to install the requirements Txt too.
Oh, yeah, that's true. Yeah, so you first have to run a, I'll type it here, but it's Pip Install Requirements Txt. But
-r requirements.
Yeah, -r. It's shown in our actual GitHub page. So if you follow those instructions, you'll get to where I am. But yeah, once you get those installed, we'll go over the web app that will be run. Okay, so the first practical tool that we have here is called the mood analyzer. Now, if anyone actually has a sentence they'd like me to input here, feel free to leave it in the chat and I can input it to see what the output would be. But yeah, I'll give you some time to do that if you like. But what the mood analyzer actually is, if you can recall from Gagan's presentation, it's actually the sentient analysis tool. So if does anyone have any sentences they'd like to? Okay, let's capture the flag. Oh, BC hacks is really cool. That's a good one too. But let's enter that in here and click get my mood. And so that will start running our process in the background. Now this might take a bit in the beginning because it has to download all of the pre-trained models. Oh, that's actually pretty quick. But our answer is positive. So because they know it's positive, our answer is you seem to be in a great mood today. So let's just take a quick look at our back end on what we actually do here. So like we mentioned before, Streamlit is actually makes it really easy to create a web application. All we really need is a couple of lines of code. So here, as you can see, we just set a couple of lines of code here for the image, the headers, and the sidebars. And we have our app up and running. Now, what the sentiment analysis actually is we take that input that the user enters, and all we really do is pass it to our pipeline that Gagan mentioned. So we call that function here, which creates a pipeline. And an important thing to know is be sure to always cache these. Because the downloads are really big, if we don't cache these machine learning models, it'll take us a couple of minutes every time to run our code to get our mood every single time. So caching is very important. And after we pass it through a pipeline, we return our answer. And with our answer returned, if we can see that it's positive, we can write something. If it's negative, we can write something else. But yeah, so this is, as you can tell, it's really, really easy to make this. If I'm sure that all of you guys can actually make this yourselves if you take a quick look into the code. But yeah, so that's the mood analyzer, which is the sentiment analysis. The next thing we have is help me write my essay. Now, you guys can probably guess what this one is. It's the text generation tool. So if we give them a blurb of what we're trying to write here, so say we want to write machine learning can help to, and click finish my essay here. It'll take a couple of minutes to run, but since I already have it pre-cached, it runs really quickly, and it gives us some answers we can use to complete our essay. So here we have machine learning can help us to transform our understanding and to increase awareness and blah, blah, blah. So that's another user-friendly tool as opposed to text finisher. A third tool that I have here is called Help Me Write a Passage. And if you can remember, this is actually the summarization tool. So if we pass in a block of text, so I have a block of text here and I'll just copy and paste it in. And we click Get Summary here. This will summarize that huge block of text into a couple lines for us to read. So this is like a TLDR. And if we take a look at the code for these two functions as well, they're very, very similar. All we do is we get the input again from the user. And then once the user clicks the button, we call our machine learning model function, which again, just uses a different type of model depending on what we're trying to do. So here we're trying to generate text, and here we're trying to summarize text. And once we do that, we return our answer and we can display it. So those are very simple applications for some of these high-level machine learning tools. The last one on this web app is called Wikipedia Answers. Now this one is slightly more complicated, but it follows the same principles. So here we can ask Wikipedia any question. So if you have another question you would like to ask this, feel free to leave it in the chat right now and I can input it in. But what this code does is it kind of builds on top of the other tools where it actually will Google search your question, and then it'll bring up the first Wikipedia article and take that article and parse the text. And once we have that text, then we pass it on to a machine learning model and we can get our answer. So if anyone has a question they'd like to ask Wikipedia, leave that in the chat and I can enter it in here as well. But okay, I think I see someone. Winners of top hackathons. Okay, let's do that. Okay, let's get our answer for this and let's see what Wikipedia says. So this might take a while again to generate, but I'll go over the code real quick. So like I mentioned, what we do here is really similar to what we did before. We get the input from the user, and once they click that button, we will get the Wikipedia article through a quick Google search library. So this library is called just Google search. And once we import that, we can find the URL that is Wikipedia, return that first URL. And once we get the URL, we use Beautiful Soup to parse the text out. And then we pass it into our machine learning function, which this case is the question answering machine learning tool. And then we get our answer from that. Now let's see. Adobe apparently is the winners of top hackathons here. But if we do another thing such as we can write, what is machine learning? And see what it gives us for that. This might take a bit to run, but yeah, so our answer to that is deep neural networks. Okay, cool. So yeah, those are some practical applications that we use Streamlit for. Another practical application that I thought of was actually based on my previous hackathon project. So for my previous hackathon project, I built a Spotify player that would display your lyrics. So I thought it'd be cool to use machine learning to actually take those lyrics and then translate them to another language so that the user using the application could better understand and better learn a foreign language. So what I did for that was I created an API. So if we take a look here, I created an API that takes a song title as well as a song artist. And then with that, we follow the same steps as our Wikipedia answer machine. So we Google search this, the song title and the song artist. We get the first URL from genius.com, which is a lyrics provider. We scrape that URL and then we scrape the text, we pass it into our machine learning function, in which this case is the translate one. And then we output whatever comes out of that. And so the full thing in effect would look something like this. So here I have it already connected to my phone, but if I press play here, I'm not sure if sound's enabled, but I can enable that. So we can listen to our Spotify music here, as well as looking at foreign lyrics in case you don't know English and you're trying to learn English alongside. So that's kind of like a full-blown application of how you can use machine learning tools in your hackathon projects. So if anyone wants to take this hackathon idea and expand on it, feel free to. But yeah, with that, I think that concludes my part of the presentation. I hope you learned a lot from this machine learning intro and you took something away from it. And from there, we'll be moving on to a Q&A session. So if anyone has any questions, feel free to raise your hand or use the chat function and we'll try to help you out.
Awesome. Thank you so much, guys, for the wonderful workshop. I think it was really helpful and really enjoyable for everyone. I have the GitHub repo for this workshop in our Notion, which I'm about to drop in over here in the chat. And this will have all that lovely information. So, and you can always refer back.
Yeah, hopefully, I guess one of the main takeaways we wanted to give you guys is just show examples of how easy it is to take advantage of these machine learning libraries to implement different machine learning and natural language processing functions into your projects, like sentiment analysis, Q&A, etc. Unfortunately, we didn't go too much into like how these like pipelines work and how pre-trained models work, but hopefully you guys can play around with our repository and maybe implement some of these into your own projects.
And there are always like loads and loads of resources online to learn more about the technical specifics. So if you are interested, you can always jump in there.
For sure. We linked a few resources that we found useful in the README as well, if you scroll down to the bottom.
Perfect. Great. I will add those directly to the Notion page as well.
Awesome. Yeah, I think I do see a question about it. And so like I think GPT-3 is actually a new version of GPT-2 and it's actually been trained on way more. It's actually been trained on like 96 more layers. And so it's actually a much more complicated model. But as far as I'm like how much I've played, I think GPT-3 is way more accurate as well. And again, so HuggingFace Transformers also do have support for GPT-3 as well. And also I'd actually recommend you guys, so if you wanna play around and implement with like in the hackathon, you can also look at BERT models, which is just BERT and all caps. And if you just Google that, you can find a lot of different models which are related to GPT-3 as well, where we do have a lot of text generation involved in it. And they're sort of simpler than GPT-3 because one of the things with GPT-3 is what usually happens is since it's a heavy model and it's been trained on a lot of different data sets, it usually has the power to overload your machine and can slow down the server as well. So we really would not want that for a hackathon at least. So yeah, I think I definitely recommend you guys to check it out. We do have a few links on our GitHub repo as well, so you can just go through those and maybe get a better idea of how you can implement GPT-3 in a hackathon as well. Awesome. Yeah, does anybody have any other questions or any chat or any discussion? We can go ahead.
Looks like we have a question.
Um, yeah, so I think how Keras is related to TensorFlow is, I think that's a pretty broad topic question though. But I think they're two different types of they're two different machine learning models, like ways how we can actually build machine learning models. And so Keras is also is pretty similar to TensorFlow as well. So you can just check them out. But they do have different applications, and and you can come up with much more different models as well. Um, yeah. Okay, thanks, Amit. And so I think one of the easiest ways to actually just implement like ML with anything is to create a wrapper around an ML model. And see, so the easiest way to do that is maybe just build a Flask API or a Fast API. I'd actually really recommend using Fast API because its performance is far superior to any other Flask API, its comparisons. And other things, and it's also been optimized to hold a huge amount of data in its cache as well. So it becomes really easy to just build models one go. So so once you do build a model, or you can just use any of these pre-trained models as well. So the easiest way to do that, and I think Richard also did this in his like first project where he did show us a really cool a really cool API as well. So we just have to create a wrapper around the model, and so that we are able to query the model and get the results in real time. And once we do create an API like that, it can be easily integrated into Flutter as well. Yeah, I think to get started, yeah, Justin, actually, do you want to show the roadmap again so that we can?
Sure, I'll stop sharing then. And Justin, you can bring that up.
Justin, if you're trying to talk, I think you're muted.
Sorry, you're right. But yeah, actually, this is a great question I want to ask again as well, because he has the most experience working in the machine learning field as well. But yeah, if you want, I can scroll wherever. If you want to like explain your path as well, how you began like work on these projects.
Yeah, so like for me, I think the best way, like the easiest way to like get started with ML is to read papers about it. And I think just like try to like implement what has been done in the papers. And so there are a lot of papers that do have like a functional code as well, and a lot of papers that do actually explain how things work. So the easiest way to learn about these things is to read those technical papers and technical articles. And they're not even like, most of them are not even really hard to find. Maybe just like a simple Google search will lead you to like hundreds of Medium articles or just like technical papers that you can find. And I've actually just learned I've actually learned more than like any of the courses that I've done from these papers, because they actually teach you how you can actually apply that knowledge of like whatever you have gathered so far. And so once you are actually able to apply that knowledge, that is more valuable than actually just knowing the stuff. So, and there are a lot of things that you can learn, that you can just check out the roadmap that we have here. But yeah, I'd actually like definitely recommend you guys to just take any paper and just try to like replicate the results that they have come up with. Because in just going through that process, you'd actually like experiment with a lot of different new things. And maybe if you do like come up with a new feature that they can improve, that is always a really good thing, and that can always help you learn in the future as well. And yeah, I think a few papers have already been linked to the GitHub as well, and we'll keep adding more stuff to it later on. So you can just like maybe start our GitHub repository and keep it on hand as well. Yeah.
Yes, it is available on GitHub, the roadmap I just checked. And it's also in the Notion as well. I made its separate link for it.
Awesome. Yeah, I think does anybody have any other questions or?
Yeah, and also I think just to confirm, you three are going to be available during the event for mentoring, correct?
Yeah.
Yeah,
Awesome.
I'll be floating around in Discord. So
here and there. Awesome,
Especially
great.
if you have like questions about like Streamlit or anything, and you want to like
Yeah.
try making a quick web app. Yeah, we'll be there to help.
Perfect. Yeah, so they'll be available to help you out if you have any questions or issues during the event. Yeah, so if anyone has no more questions, and I think that will wrap up the workshop. Thank you very much, Google DSC, for coming and giving this wonderful workshop. It was very insightful, a lot of very useful information, and hopefully some of you will go on and make something really cool with what you learned today. So right now, the